Hi everyone, my name is Aleta Mkrtchyan and I'm excited to present my capstone project titled Design and Construction of Rotating Drum and Silo for Granular Flow Analysis, which is supervised by Dr. Aleta Mkrtchyan. So let's understand, first of all, what granular materials are. Okay, granular materials are materials made of macroscopic particles where at least 100 of the particles are like in micrometers. So, as you understand, granular materials can be found in many different spheres. It is estimated that 70% of granular feedstock is granular at some point. So, besides being in the food industry, granular materials are also found in nature. Here you can see the good example of granular flow, such as snow and soil. Probably all of you have walked on the sand, and when you step on it, you feel like some weight acting on the sand. So it is similarly the same granular flow as mentioned before. When snow and soil flow, it can cause natural destructive phenomena, such as avalanches and landslides. Those phenomena we still don't completely understand, but the mechanics of this phenomena is being on researches and scientific papers. And those scientific communities are still trying to understand all the issues that it may cause and how and what we can do to prevent this kind of structures. So, to better understand how the granular material flows and what are the dynamics under that, as capstone project, I'm going to present two devices. First is the rotating drum, and the second one is the silo test. So here you can see those devices are demonstrated here. So rotating drums are routinely used in industry. They are mostly used for mixing different granular materials. And in industry, rotating drums are usually larger than they are supposed to be. So they may have different structures and different outer structures and different internal structures, which is based on what they are going to mix. So in some cases, it may also crash the mixing materials as well as the mixing processes. This process of mixing is widely used in agriculture, in construction, in food processing, in many other spheres also. So the mixing drum serves as a controlled environment to study how these granular materials behave under some circumstances, especially under centrifugal force acting on the particles. I would also like to mention that those kind of industrial drums are not only mixing one particle, but also they are testing several kinds of particles. You have probably seen in some cities or while traveling these kind of structures. Here are shown the industrial silos, which are very large. But today, as an experimental one, I'm going to represent a small-scale silo, which is constructed in a cylindrical way, and it has a pointy edge. Those silos are widely used in industries, such as in chemical industries, also in food processing, and the main thing that they do is the discharging of the particles and the materials inside it. So understanding how this flow works may help us to design better silos and to construct better structures. Silos are not only used for storing, as I mentioned before, they are also used for finding out lots of problems while doing the discharge. So it also helps us to understand the complex behavior of particle interaction during the granular flow. So here, you may think that those kinds of simple devices are not that famous, or we can say it doesn't mean anything. But here you can see the research papers demonstrated here, which were published in the last year. In the right picture, This shows how the particles are behaving under some other circumstances and how different particles are behaving. On the picture shown in the left, you can see how different kind of particles are demonstrated of different speeds. So here is the same with the discharge of silo. The picture shown on the left demonstrates how the particles can have an effect on the walls of the silo and how it can be affected during the process and also in the final, the discharging process. On the picture shown in the right, you can see some researchers conducted this kind of experiment. So they put the vibration inside the silo and tried to get what kind of effect it can have on the discharge and how this vibration may cause numerical and other scientific issues. So here you can see the initial 3D model of rotating drum that we wanted to construct. It is basically made of like a cylindrical drum, and you can see that on the side of the drum is the DC motor, which we used to do all the processes. The drum is based on two bearings, and we think that I would say that this system would be in the best structured way. Then the simple device and the 3D model of the silo is here. It is very similar to the one represented today. And I want to mention that most of the most important parts for the silo are the angle and the radius of the tip, as the angle may cause lots of issues mentioned before. So as same in the picture, and here you can see the rotating drum. The rotating drum is constructed like we changed the design of the drum to be constructed in a better way, so that all the pressure will not be only on two bearings, but in four bearings. So the drum will have its own, I would say, like the pressure, and the pressure will not only be on the DC motor axis. And also the two parts of the rotating drum are transparent, and it helps us to capture all the moments that the angles are like when we are rotating the drum, as the angles are changing, so we have to capture it in a way so they are transparent, so they are see-through. And here you see the left picture is the drum. It is filled with buckwheat. So the line of the angle is like just horizontal. It's about 180 degrees. But in the right picture, you see the drum after several rotations. So here you can see the angle difference, and it is I would say, one of the main properties what the future research is based on. And it also, so we can also add other materials here, and the angle will be totally different one. Here is the small video demonstration of how the drum works. I would like to mention also that the drum is working with the power source. The DC motor is about 24 volts. Okay, and now for the silo. The silo's angle is about 30 degrees. We came to that conclusion from like doing a different literature review, as the angle varied from 30 degrees to 50 degrees. But this one is like the, I would say, the average angle that it is used in many, like while building this kind of structures. So here is the silo, and this is very small video of how the discharge is done. Also, like here we have that thing that, so inside the silo it must be very like good structures, so the particles will not stay there and will like the discharge will be immediately. So we also face that issue while doing the silo, not only that part but also the part where the edge is connected to the cylinder. So future work, rotating drum and silos are very significant, I would say, devices that we use in everyday life. So some other future work that must be done following the research is that we need to find all the angles, all how the discharge is done and everything was done. So it must be converted to all numerical results and simulations. And while building this capstone, the further work for this is to simulate all the data and try to understand how it works is like the best way. So thank you. That's all.
Hi.
Yeah.
I happen to have a very good friend who works at a company called Johansson and Jennings Johansson, Irene guy. I can give you contacts. This is what his company does. They're trying to find a closed solution for silos without taking a hammer and hitting it because they get clumped up. And it's as far as I know, there's some solutions for certain size particles, but there's no closed solution. You may want to contact him.
Okay.
It's a company in Massachusetts. He's the CEO. And as of maybe like 5 to 7 years ago, they still didn't have a closed solution. For the angles, do they shake it? How much do they vibrate? Don't they vibrate it? Do they put pressure in it? Is it in the vacuum? All these kind of things. It's almost a fluid mechanics, but it's not. Because they're just too large.
Yes, like
it's sort of interesting.
There are also another kind of silos where like this part is like up to here, but the discharge is like very different from there.
They also have one that goes like this, but it's very expensive. It's still not a closed solution. This is interesting stuff, actually.
Yeah, so like the main goal for this, for like further research, so better structures can be built. Like it would have its perfect like timing, the discharge angle, and everything. Yes.
I have a broad question. You looked at a lot of different systems or aspects. What was the specific, most technically challenging, let's say, problem you solved through this thesis or through this capstone work?
Yes, for this silo, I would say the material choice, because we thought like several materials of what to build it, but we also need to find like a cheaper one, and we use like metals there. But I would say that part was the most like challenging one, because we tried lots of like other materials, but this one is like just a basic tube, and we tried to like adjust like the edge part to that. So it was I would say also the angle of this, as like lots of properties are dependent on the angle. I would say like.
And that's through calculations and simulations, or what would you say the choice was the basis for your choice?
Yeah, firstly the literature review. Like I tried to estimate, like I know that the angle is going to be from 30 to 50 degrees, but then when we like had the tube, so we need mostly trying to measure approximately what kind of angle is like best suitable for the tube. So I think that's how we like came to this conclusion.
Thank you.
Can you give a little brief context where this came from actually? How did you end up with this?
Yes, so my supervisor, Dr. Mkrtchyan, is like a part of a research, and I would say like he suggested us some projects. So I thought that this is like can be option for my capstone project, as it was also interesting how the drum, especially the drum for me was like more interesting how it was working. I would say that was the main motivation, but after like doing literature review, I personally like didn't have the idea that this kind of devices can be that important, and like they may cause like the issues I like I don't know, maybe knew after the literature review or the structures we would.
And in the industry, I guess so. Based on the structure or based on the material of these grains, yes, it can be very different physics inside.
Yes.
For each one, you have some parameters to take care of, and then the structure, maybe the solution structure can become as a solution for some specific cases. And is there any like a research which particles are better in which angle, and for drum, for example, if it is mixing, if I, for example, I'm a producer of this drum, yeah, what I'm mixing inside, and what is the heat, what is the pressure on the drum, and etc. So I would like to understand where it will go now, to the production of such a system,
yes.
or where?
So it will go on a like full research of, for example, like here the backward is shown like how we rotate it and what like is the angle of repose. But for example, when the backward is mixed with wet, it like has really different properties. So all the analysis may be based on that. So like we can even like try to compare soil to snow or different kinds of materials. So each of the materials is different in their own, but when they are mixed together and like rotated in the drum, their like results are completely different. So this research will be like, it will be for further researches.
For example, interesting question. For example, what should be the volume of that material inside the drum to not like destroy it, let's say, and how you calculate it, and what it is something that comes from the manufacturer, yes?
Yes.
But the manufacturer already do the research and measure it, and then create the data sheet and say this is.
I would say like not all the data analysis are done in the scope of Capstone project. It was mainly for building this and like making it available for the further research. We just did this for like having an initial like guesses of what maybe angle of repose can be while doing this like the rotation. And same with the silo. Like for example, when we were trying the buckwheat with the silo, we just like hold it and then just try to do this. Like it was like spread all over the room. So I think it would be better to understand what to do for the silo, so it will not like just spread all over there.
You've done a literature survey and then built, based on some literature survey, you've built 2 silos. What I would have liked to have seen as part of your contribution to this was some simulations. There are really powerful software out there that can do this granular flow. And you showed a few papers which have used some of that software, which is familiar to me. There are mathematical models that have been put forth in the last, I would say, 10 years. I wouldn't say they fully nailed down the problem, but they do a pretty good job. So I think there could have been some predictive work that you could have done and shown that this is my prediction for that and that using these 2 simulations, and then showed that whether the prediction is okay or not okay. I would have liked to have seen some sort of contribution like that. So that would be my comment.
Okay, thank you.
On a mechanical side, I'm quite confused why you chose the direct drive drum rather than to have some pulleys or have a rotating rollers to make the uniform pressure of the drum and the rollers. It's quite confusing. Your apparatus will crack very quick. Why you chose this way to?
I think like we choose this for is cheaper, like for being cheaper, just for like the further research. But here we tried like rotating of the different speeds, and I would say that it was like doing its job very good. So like the DC motor is
Yeah, well, you still could have a DC motor, you could have a belt drive, because the belt allows some slippage. In that case, your drum will last much longer. Even if it's for education purposes, you try to visualize the granular flow, but you could have much more uniform pressure stresses rather than with direct drive. Anyway, I understand your reasoning, but I will do differently. And also with the silo, there is very easy thing to do with diaphragm to adjust the opening size. Whereas this way you have a constant silo, which is not adding any research value. With the diaphragm adjustment of the opening, simple one, but your research will go from 1 to 100 scale. More questions? Okay.
Thank you.